What up, Hyperchange? We have got an epic episode today right outside Starcloud, a startup that is based here in Redmond, building AI data centers for space. This is straight out of sci-fi.
This is going to be way thinner, for example.
It's
this
so...
is just a mock-up.
Whoa. A sneak peek into what the space economy will look like if SpaceX and Starlink are successful. All right, so we're here outside Starcloud with CEO and founder Philip. How's it going?
Going well. Great to have you with us.
Yeah, thank you so much. Stoked for the tour.
Yeah, of course. Excited to have you.
Testing, testing, testing. So what do you call this? The control room or something?
So this is for electro engineering mainly. It's mainly to test the different setups. So here we have different configurations of H100s, H200s. The Blackwell chip we're testing for the second satellite. We can see which configurations make the most sense. And after that, then we would put it into the radiation testing. So shoot proton beams at it at 20,000 kilometers a second. And we run the workloads that we're going to be running in space while it's under that kind of stress. I think we're the only people in the world now that know where an H100 will fail if you shoot it with protons at that speed.
Wow.
Our first launch is in 3 weeks. That's going to have the first H100 ever flown in space. Wow. It's about 100 times more powerful GPU compute than has been operated in space before. And then, yeah, the next one going up in October will have at least 10 times the compute capacity of the first one. It will have by far the largest commercial radiator in space. And the plan is to scale up so that in the early 2030s, we're building extremely large multi-gigawatt data centers in space, mainly for the energy. So we're facing enormous constraints on energy terrestrially for powering data centers. In space, we have almost unlimited low-cost energy in the form of solar. The only additional cost we have is the launch cost, but that's very rapidly trending towards, trending down as we have Starship and other launch vehicles coming online.
Wow. So Starship itself sounds so transformative that's really changing the economics, because it seems crazy to think a data center in space would even be remotely feasible. But I've been listening to you on some podcasts and learning more about it. It's interesting to hear that this is actually a reality, and it's like you're literally sending this thing to space on a SpaceX rocket.
Yeah, actually, and this is an AWS outpost. That's the on-premises hardware that AWS usually delivers to customers. We've got an agreement with them to be the first to fly this on-prem hardware in space. So we're ruggedizing it. We just put this through vibration testing. What that means is that our customers will be able to essentially run an instance of EC2, the AWS front end, on a satellite in orbit. So they don't have to downlink enormous amounts of raw imagery or other data. They can run all of that inference and other processing they would normally run on Earth. They can run that in space on this piece of hardware.
And that unlocks a certain business case for this. Like, this isn't even a test. This will actually kind of be operational in some ways.
The second satellite is a commercial offering. So it will generate more cash than it costs us to design, build, and launch. That's the one launching in October next year. The one that's launching in 3 weeks is fully designed, tested, and built. So we did that in about 18 months. I think we might be the first, or the fastest ever for any startup. The fastest I've ever heard from a startup is going from 0 to launch in 4 years. We're doing it we were ready in 18 months, but it will launch in 22 months because it got pushed back a little bit.
Wow. I have so many questions about what it's like to be like a SpaceX launch customer, but it sounds super cool. So you're literally launching on, what kind of rocket
Falcon
is it?
9.
Falcon 9.
We were down in Cape Canaveral last week where we were integrating the satellite onto the launch vehicle. It's become incredibly easy, or much easier to launch stuff to space than it was even like 5 years ago. So yeah, you notice we keep everybody in this main assembly room. We don't have anybody working in offices. That's my desk over there in the corner. So here this is a zero-G rig. So we've been using this to test different deployments of solar panels. So that's this.
Oh, that's this thing.
This thing here, yeah. So you essentially hook up different solar panel configurations, and then that allows you to test the deployment under kind of similar to zero-G configuration.
Wow.
And then behind here we've got Juan, who's building various radiator components. So there's two key IP aspects that we're developing. One is a very large, low-cost, low-mass deployable radiator to dissipate all this heat. And the second is making these chips work in a high radiation environment. So we're a team of 11 now, of which 7 are working on the radiator and 3 are working on making the chips work in a high radiation environment. And that's split roughly between my co-founders, our CTO and our chief engineer.
Hey, my name is Juan Toga. I've been a thermal engineer for the past 11 years. In that tenure, I spent 5 years at Raytheon, 4 and some change at JPL, where I worked on the Europa Clipper program, handling the thermal hardware on that. And right now we're testing some of our cold plate components, just making sure we can actually dissipate the high heat density that these GPUs dissipate.
The way that a terrestrial data center keeps cooled usually is they boil off enormous amounts of fresh water or they're blasting air through it. We can't do either of those in space. And so the way we do it is we run coolant past the chips and then out to a very large deployable radiator. And then that emits in infrared the heat out into deep space.
Do you think it's inevitable that we will have compute in space?
Yes.
And will it be more than compute on Earth?
It will be much more than compute on Earth. It will probably be 99% of all compute.
Wow, we'll be in space.
We'll be in space. So on a 10-year time frame, within 10 years, most new data centers will be being built in space. Now, it's going to take a long time to replace the stock of data center on Earth. So, a data center lasts 20 or 30 years. So I don't think we're going to be decommissioning the data centers in 10 years. So, that's going to take a while. But on a sort of 50-year time frame, we're going to have much more compute in space than we will on Earth.
Wow.
And, maybe I'll just highlight these boxes. So,
and Starcloud is like the first, is anyone else doing this? Like you guys?
There's lots of people who say they're doing data centers in space. Nobody is doing compute on this scale. So we're just boxing these up to ship them down to do radiation testing.
I wanted to see that box that's actually going to space. Is it possible? Because that was kind of cool.
Yeah, sure. So this is the actual form factor of the second satellite box. So we've got, within this, we're going to have a whole bunch of H100s as well as this AWS hardware.
So the H100 that we saw over there, you're modding to put in this box, which then goes into space and runs customer workloads in October next year.
Yes.
Wow. And can you explain a little bit more about who the hell's your customer who needs to pay for a space data center?
Initially, it's other satellites. So in the end state, we're planning on competing with all terrestrial data centers on energy cost. But for the next few years, we're expecting Starship to start launching commercial payloads on a sort of 2-3 year time frame. But until that point, we're going after a much higher value, smaller workload, which is running inference for other satellites. So imagine there's satellites producing enormous amounts of data, be that imagery, be that SAR, synthetic aperture radar data, all these kinds of things. What they have to do now is they wait for ground station and then they downlink as much as they can. And usually that's a very small percentage of the total data they're collecting. When we're in orbit, they'll be able to ship all of that data to us using an optical terminal, and then we can run inference on it in near real time. And then we just downlink the insight. And that insight might be, there is a vessel in this location moving in this direction. Or it could be there's a wildfire, started in this location, rather than having to wait a huge amount of time for that.
It's so cool that there's already like practical applications about this. And how do you feel about this whole like Starlink, SpaceX, Starship ecosystem? Because it seems like they're building these sort of platforms for the space economy. And it's been hard for me to imagine why the hell we need a space economy or what's going to happen besides just going to Mars. So this seems like such a cool application. So do you think of yourself as almost like one of the first space companies on these new railroads? And like, is that what got you excited about kind of this mission?
Yeah, to be very frank, I went down to Starbase, Texas in 2023, and just seeing the scale of what they're building there in terms of these Starship gigafactories made me realize, okay, the launch cost is going to come down by an enormous amount. Maybe 10 or 100x, but what's really interesting is the launch capacity is going to go up by maybe 1,000x. And the reason for that is Starship's the first ever fully reusable rocket. And what that means is, let's say, for example, you build a new Falcon 9 every day for a year. At the end of the year, you have only one Falcon 9 because the upstage is dispendable. If you build a new Starship every day for a year, at the end of the year, you have 365 Starships.
Wow.
And each Starship has 5 times the payload capacity of a Falcon 9. Each Starship can launch maybe 10 times as frequently as a Falcon 9, even the booster. And so, what's coming down the line in terms of capacity to get stuff to space, like tonnage per year, is mind-blowing. It's really difficult to comprehend even what's going on.
And I feel like that's because Elon has this vision of like, you got to launch all the rockets at once to Mars, and then they come back every 2 years. And then it must help the economies of scale to have other people using the Starship.
Yeah, so you might say, why are they doing this? Because there's no commercial demand for the amount of capacity they're building right now. And that's a good question. And the answer seems to be they really want to get 1 million tons of cargo to the surface of Mars. And we can jump out. It's all right. Yeah, Yasim, you can come.
All right, thanks.
Yeah, we're good. And
action happening here at HQ.
So if you want to get 1 million tons of cargo to the surface of Mars, you need 10 million tons of cargo to low Earth orbit. And that's about 10,000 Starship launches, which is about 3 Starships a day over 10 years. And that's the capacity they're building for. You know, in terms of will we be able to access that capacity? Well, they can only launch those every 2 years. So that capacity is going to be sitting there for 2 years. And either they just leave it there or they try and earn some cash from it. And their marginal cost of launch is extremely low. Marginal cost of launch might be $2 or $3 million, as in the fuel and labor per launch.
Yeah.
And so why not charge $10 or $20 million to us to launch, which is at least, you know, it's close to 100 times cheaper than today in terms of per kilogram. And then, you know, they make some money off it while it's sitting there. So that's what's coming.
And so a second ago, you were like, SpaceX is building for all this commercial demand, but there really isn't any. But on the flip side, you're creating a business that's like, wait, like we're ready to take this commercial demand.
Yes.
I'm sure a lot more people, like they're kind of building, like if they build it, they will come.
Yeah. So there's a few other use cases that people are building for. One is manufacturing space. Another one is asteroid mining, lunar resource mining, you know, companies like Astroforge and Interloon and these guys. All of those will be possible with much lower launch costs. I would say we are by far and away the heaviest user in terms of total tonnage need. So we can make use of 10,000 tons worth of payload capacity. Like that would be like a 5 gigawatt data center. It's about, you know, 100 Starship launches. I'd say we're both the first use case that makes sense economically, because one of the key things about what we're doing is we don't need to re-enter a product. That's really expensive. Re-entering a product is really expensive.
Yep.
We're both the first, and we're also
like you never bring it back. You only send back the data.
We're just sending back the data. Exactly.
Yeah. Gotcha.
But we're also maybe the last and largest business ever, because we're heading towards towards building a Dyson sphere, right? And Starcloud is the first.
What is a Dyson sphere? Because everyone's always talking about that.
Dyson sphere is where you surround a sun or a star with as much solar. You put orbital solar panels in orbit, and then with that you can build what's called a Matryoshka brain, which is you hook up a Dyson sphere, you know, the surrounding a sun with solar panels, to as much compute as a star system will physically support. It probably takes about 10,000 years to build a Matryoshka brain. We are the first company ever whose natural extension is to build a Dyson sphere / Matryoshka brain.
Wow.
So
that's insane. Has the acceleration of OpenAI and XAI, has that given you more confidence as you've seen them kind of accelerate since you started the company? Because I feel like that's such a big thing, is like, will the end demand?
Yeah, definitely.
You know,
I mean, we can see it coming down the line now. I mean, you can see what's happening with energy prices in the US. Electricity prices went from 10 to 20 almost in the last few years alone, and there's a possibility they could double in the next 5 years because of the requirement for energy to run these huge data centers. So,
wow.
Yeah.
And I feel like it would be such a cooler future to have like the Starcloud in space. Like, doesn't Jeff Bezos talk about the thing of like moving all industry and heavy manufacturing to space?
Yeah.
And to make Earth be preserved better. So I feel like Starcloud to me seems like such a, if what you're saying is right about 99% of compute eventually moving off Earth, it's like, all right, well, we should get that going as soon as possible before ruining.
100%. I mean, yeah, 100%. It doesn't make sense to cover all of the countryside with solar panels to power data centers, which is what's happening now, when you can, if it's all going to be in space anyway, rather get that going now. Yeah, and in fact, Jeff Bezos a few days ago gave a very interesting speech where he was saying all compute's going to space. He literally said within 10 years, a gigawatt, gigawatt-sized clusters will be being launched into space.
Wow. So he was talking Starcloud.
I mean,
basically.
I mean, we're working with the AWS team. I don't know if he's seen what we're doing, but we're super keen to work with them. So, so this machine here is to test the strength of different welds.
So, one of my questions is, Starcloud seems like one of the coolest startups. You guys have raised a ton of money. I'm trying to invest, but I can't even invest. It's too exclusive. So how did you get the je ne sais quoi of startup hype to kind of be able to raise capital for such a crazy mission?
Yeah, maybe I'll just talk about this room. This is a more like dirty room where we're doing welding and fabrication, things like that. How did we get, I mean, I think investors see that we're in this like trifactor of like mega trends coming. One is launch cost is coming down rapidly. Second is demand for AI is going through the roof. And the third is that is causing energy prices to go through the roof. And these three things combined, I think, is smart investors can see, holy shit, run this forward 5 years. It's like actually a pretty obvious thing that we're doing. Yeah, we won't go in this laser room here.
Wow, this is like every guy's dream, this toolbox.
Yeah.
This is cool. It's really refreshing and awesome to see like such startup energy in the Seattle area, because I grew up in Seattle and I feel like I never see a cool startup in Seattle.
Oh yeah. I mean, I think don't film in there, please.
Oh yeah. Whoa, top secret.
Yeah. That's our secret sauce in
wow,
yeah.
Secret sauce, love it.
Yeah. All of the talents here. Like we started down in El Segundo where where
the Gundo.
SpaceX is. Yeah, people told us we need to be there for the space talent. It's true, they have people that know about launch and propulsion and aerodynamics, but everybody that knows about building satellites is in Redmond, because you have the entire Starlink team here, you have the whole Kuiper team here, and then on the data center side you have AWS and Azure. So, I mean, we were literally in El Segundo typing into LinkedIn like spacecraft thermal engineer, and it would go Redmond. This is a vibe table where we're testing a bunch of. In fact, we might try and get this set up, and you can. We're testing some of the hardware yesterday.
So this thing was a cool. You were trying to explain to me. It's like simulating the rocket launch.
Yeah. So the whole thing. This thing vibrates at every different frequency. So you need to make sure that there is no, what they call a mode, which is like where you have resonance at a certain frequency. Because what that can do is, if you have all of these frequencies combining, you can end up with much higher stress on the payload than you might imagine.
Yeah.
And so this basically simulates that. It will, in this one axis, and then we turn the whole payload and do it on different axes. It's very noisy in here when this runs.
We've got super cool. So it's just literally like.
Yeah. It's like, as you would have seen from outside, like it looks like a kind of like an office park, and like next door is like, there's like a nursery next door, and then there's like a thing up here. This sounds like a jet engine when you turn it on. So we usually don't run it too long or too during the day. Yeah, we can fire up the vibe table if you want to see what that looks like.
Ooh. Damn, this is cool.
We can jump back in.
Rumbling. So, what the heck is that thing? You guys
vibration table.
But like you need energy to power.
Yeah,
it?
it's very like
you can't even just
hungry.
plug it in. You need have like this whole cord on the floor.
No, we have. Yeah. This is a lot more power than this whole facility can draw. So.
That's hilarious to me that you guys.
This is the cooling system.
Wait, this is okay. This is. I'm so glad we're getting this. This is hilarious.
Yeah,
just
this
like
is
in
a bit
this
janky.
office,
I'll admit this is janky.
Simulating a rocket launch here. Like, this is epic.
I mean, literally, that's what we're doing. Simulating a rocket. Yeah, so you can.
Audio may get choppy.
So yesterday we had the AWS outpost strapped to this thing, and then it will go like, you'll see it's going to go like shaking up and down. Yeah. We'll do low frequency so you can see it, but when it's high frequency you wouldn't be able to see, but now you will.
Oh wow.
A version we saw next door, but this has been sealed and pressurized. Will be pressurized, and then we're going to now test for leaks and.
Wow! So this is kind of almost the coolest part to me, because this is like the thing.
This is what's flying in October next year. This is my co-founder Ezra, by the way.
So hey, I'm Ezra Fielden. I've been in the industry for about 10 years. Worked at Airbus Defence and Space, where I designed the deployable solar arrays for NASA's Lunar Pathfinder satellite. After that, I've designed several other large deployable structures, large deployable antennas, deployable solar arrays, and now I'm the co-founder and CTO of Starcloud. and I also lead the mechanical team here. I've worked on some pretty large satellites, but we're really defining a new scale in space here. We're doing something pretty unusual and special. So no, I've never had the opportunity of doing something at this scale before.
A rough version of it. Don't think this is what it's going to look like at the end. I mean,
No,
this is going to be way thinner, for example.
It's
this is just a mock-up. This goes bolted to a bus, and the bus has connectivity, has large solar panels and radiators. We're doing all of the connectivity, all of the energy, like all the power and thermal systems. So.
Wow. I'm asking to see the NVIDIA chip one more time because how could you not? You guys haven't met Jensen Huang yet, right? He didn't come hand deliver it?
No, sadly not.
Because I was thinking if I was Jensen, this would be one of like the coolest H100 projects that is like happening right now. Like, wait, these guys are like sending this on a SpaceX rocket? Like, you know he's thinking it's cool.
Yeah, Jensen, if you're watching this, we would love to speak to you about this.
The problem is you're only buying one or two. That
Yeah, right now we're only buying one or two, but I think we're going to be his largest customer ever within 10 years. So.
Wow, I love that.
The RTX 6000 Pro Blackwell.
Ooh.
This is the Blackwell.
So this
Not
is
many people
the.
have this. It's very hard to get these.
Whoa.
Partially disassembled.
Whoa.
You can sort of get a view from the side.
Do you have it? Do you have this
This
one?
is an H100 94 gigabyte.
Whoa.
Be very careful because there's no heatsink on it, so it's very vulnerable. But yeah, we've taken the heatsink off. We're using this we're using this with our thermal test rigs to figure out how to cool it in space. We use this to drive GPUs in radiation chambers. Radiation is a hazard that we always expect in space, so we test our GPUs on the ground in particle accelerators that generate a radiation environment like that in space, make sure that they'll work on our satellite. Amazon produces this rack mount server to use so that you can set up an AWS on your premises. We plan to fly this in our next satellite SC2, which will so we can have AWS running in space. Hi, my name is Steven Carlson. I worked at Starcloud for a little over 6 months. Before that, I worked at Microsoft for 10 years, first on Microsoft hardware products, including the Surface lineup. And then I worked on custom network cards for Microsoft's data centers, including our AI and GPU data centers. I also worked with Addy, one of our founders in the past, on both the Husky Sat satellite and a high altitude balloon project, where we launched a very early machine learning model on it to detect wildfire smoke. I wanted to join Starcloud. It's a really cool project that promises to solve problems that the explosion of AI models poses for our data centers on Earth. It's also great to work with great people that are quite smart, and we're pushing for a role that could put us into that could reshape the AI market forever.
Let's go. Love it.
I'm Bailey Montano. I'm a lead mechanical engineer here, so I'm working currently on designing the radiators for our next generation satellite, Starcloud 2. I got an undergraduate degree in mechanical engineering at MIT. Then I worked at SpaceX for about 4 years. I worked there on valves and mechanisms and actuators for the Merlin rocket engine mostly, but also for Raptor and for Falcon. After that, I came up here and I worked at Helion, fusion energy company just north of here, where I developed and led the team that manufactured the world's largest quartz glass tubes.
The world's largest what?
Quartz glass tubes.
Whoa.
Like the arc fusion crucible is where they actually do the fusion process.
Oh, wow.
Yeah, so this is the vacuum vessel chamber liner essentially for the Helion's next generation fusion machine.
And I've been asking everyone, why did you want to join Starcloud?
I missed aerospace very dearly, for sure. So, started SpaceX and then kind of did a few other things. So I missed aerospace a lot, and then saw this opportunity to just marry like two things. Space and then AI, kind of like the next wave. Seemed like a really interesting opportunity, really cool way to make a mark on the world in a big way, like a Kardashev level problem statement, which really got me interested.
My name's Dylan. I'm a manufacturing engineer here at Starcloud. I'm in charge of designing our payload structure and integrating our compute module into the satellite. I come from SpaceX. I spent about 4 years there, first working on the Dragon spacecraft program, building the crew and cargo variants of the Dragon spacecraft to take astronauts to the ISS. And then after that, I worked on Starlink Aviation as a mechanical engineer, putting Starlink on airplanes. Starcloud we're an extremely disruptive force right now, and I think in the industry we're doing something completely new that no one's ever done before, and we're the first to do it. I think that's extremely exciting place to be.
For Tesla, it was like the Model Y that like really pumped out all their profits, and then they leveraged that to get to the next level.
Yeah.
Is there like a size data center where you guys?
I can't talk too much about it, but you can think about it like a 1 megawatt size is about 4 tons that we can launch cheaply, and we can just launch versions of that. And I mean, and one other thing that makes sense is you can look at crypto mining as well, because you don't have the chips on a H100 is like $30,000 for 1 megawatt. An ASIC, the chip you use for Bitcoin mining, is about 50 times cheaper, and it still uses 1 megawatt. And so rather than having to finance all of that capex for the chips, you still have the same energy problem with crypto mining. So there's a case to be made that it's a better early use case. The sort of rebuttal to that is the competition on energy for Bitcoin mining the price is much lower. Like Bitcoin mine, using energy in the middle of nowhere at like 2 cents per kilowatt hour.
They've been working on that for years to get to the right spot.
Because they don't care about connectivity. They don't care about, if they're in the middle of nowhere in Australia or whatever, they can just use 2 cents per kilowatt hour energy. Whereas most data centers, you need the whole thing to be networked. You need continuous power and all the nice stuff we can do in space, and that usually comes at like 10 cents per kilowatt hour for a new energy project.
Yeah, so I'm Miguel Rivera. I'm the engineering operations lead. Basically, the engineers design everything, and we build it over here. Actually, this is Camilo Lopez. And before here, we both worked at Helion Energy, where we were building the world's first fusion nuclear generator. And now we're over here building supercomputers for space, so it's pretty cool.
Wow, that's awesome.
Do you want to give a quick background on yourself?
Yeah, so I ran the welding and fabrication department at Helion Energy. Before that, I have about a decade of experience working in different fabrication and welding shops. And before that, spent a decade in the U.S. Army with the 101st Airborne. And now we're basically using cutting-edge laser technology to weld up these boxes and our radiators. So basically, we're utilizing very high-focused energy.
Got to be some strong welding, I would imagine.
Yes, sir. Yep, that's correct. And so what we're doing in here is pretty cool because we're using the latest and greatest technology that there is available as far as welding and applying it to this cutting-edge technology as well. So it's pretty cool.
Awesome.
Do you want to talk about this flag real quick?
Oh yeah, so this is my old American flag. I've had this with me. It's been to Iraq and Afghanistan, and every time that we deployed overseas, we would fly it on September 11, and it was kind of a tradition of our units to do that. And it was always flown in a very precarious place in face of the enemy so that they could see that we can basically put the flag wherever we want.
Okay, well, we met the team. Thank you so much, Philip.
Thanks so much for
I had
coming.
a blast.
I really appreciate you coming.
I think this is one of the coolest startups in the Pacific Northwest. So everyone, check out.
Coolest startups ever.
Cool startups ever. Yeah. I love that. All right, I'm ending it there. Wow. I mean, these are the days where I feel like I have literally the coolest job in the world. Like meeting so many smart engineers, working on straight out of sci-fi, building data centers to space. I mean, what Starcloud's doing is crazy. Every startup is super risky and may fail, but the level of ambition here is out of control. Talking about these Dyson spheres to suck up all energy, move AI computing to space. I mean, I feel like I saw a glimpse into the future today. I'm very impressed with not only just the vision, the technical talent of Starcloud, but the way they've unwrapped this incredibly ambitious vision into a step-by-step business model to get there. And that's a pattern that I see in winning companies is knowing that playbook that gets them there and knowing exactly what to do, knowing what to de-risk. And so I feel like Starcloud is crushing it. And I have no idea if what they're doing is going to work, if data centers in space is even going to be a thing. But if they are, I feel like these guys are one of the leaders. And I mean, the scale of this is incredible, because if you believe that humanity will not only go to Mars, but will colonize all of space, then Starcloud is one of the most important companies that will exist in the future economy. Or, the companies that run these data centers in space that are where our AI our silicon gods reside is going to be a massive business. So I think something changed in my head today of now where I'm like, maybe all data centers will actually go to space. Maybe that would be a better future. Because,
hearing Philip say 99% of all compute will eventually be in space, not Earth, that kind of blew my mind. It seems inevitable. It makes sense, but it kind of blew my mind. So anyway, super pumped that I got to visit Starcloud. Thanks to the whole team for letting me be annoying and film all y'all. Shout out to Philip for touring me around, and shout out to my boy Javier, who's got a Cybertruck, and he's the one who introduced me to Philip here in Seattle. So shout out to you. Thanks, Javier. Anyway, this is Hyperchange. Let me know, introduce me to some other startups. Tell me what startups I should make videos like this about, because this is what I have so much fun doing, showing you Hyperchange on the ground. This is hyperchanging the way AI works, the way our data centers work. This is straight out of Star Wars. Like, there is not, you can't, what's a more hyperchange company than this? You know what I'm saying? Anyway, see y'all next time. Peace.